Hi everyone, my name is Joy. I'm the president of the Game Development Club, and I'm very excited to see you guys here. And today we're gonna have a very small. Oh my god! Sorry, like we're just like a very small workshop about the Unity. But I want to give a brief introduction of our club first. So our club is a very lovely small community of game developer. I'm also welcoming the people that not doing programming but also good at art and design. So the full name is Game Development and Art Club, and you guys are very welcome to join our Facebook chat, Discord chat, and follow our Facebook. There's a group called HackDavis Game Develop Club. You can just search it right now and try to apply it, and we will accept it. Yeah, and we are for the January 30, we have a global game jam events, which welcome everybody who either have or have not game development experience to our event, and we'll have like 2 days to work on a project. We'll divide people into different groups. Then we we'll have a theme, and we will try to develop a game or multiple games in 2 days, and that's a very meaningful event. And we have supports from all professors and also instructors. There will be a very fun event, and we have all the foods and foods and pizza and supports. Yeah, just come to the event. It will be very nice experience. That will be the game develop. That will be the global game jam. Again, we will post. If you follow our Facebook, we will post notification to tell guys when and where it's gonna be. It's actually at the Art Annex. Anybody know where is Art Annex? Okay, it's like behind the art building. Anyway, it's a very huge place. Pretty spacing and nice. All right. So let me introduce our officer, Sven. He will give us a workshop about the Unity. Okay, thank you very much.
Excuse me, I hope. I'm very bad with microphones, so tell me if I waver or okay. Let me just. There we go. Okay. So unfortunately, my internet doesn't work today, so I can't show you the page to download certain things, but I can tell you where or how to Google it. And assuming you guys all know how to use Google, so basically, if you haven't already, try and download Unity Hub. From Unity Hub, you can download the Unity editor, the game engine. We will be using that today during the workshop. That is, of course, if you haven't already. I'll be giving you around like 5 to 10 minutes to actually download it, because I'll do a little bit of something before we actually get into Unity, explaining why game development might be of interest to you, especially in regard to this hackathon, HackDavis, where we are coding for social good. And you might be asking yourself, what do games have to do with social good? Also, please download the Unity Workshop zip file from HackDavis at itch.io. I'll just leave that for like 5 seconds. All right? Yeah? Okay. So I'll continue. Okay, cool. So, social good. What do games have to do with it? Because I know I waste way too much time with games, and to be honest, I don't know how that really helps social good. But there are many ways that you can use things like Unity for social good, even if it isn't games. But games can also be used for social good. So, in fact, games are really challenging for your mind. And so, it's definitely very good for sort of cognitive exercise. So, especially for young people, it's very good for learning. And so, if you want to learn a topic, if you're like introduced to it through a game, through repetition and sort of these underlying concepts, you're basically going to learn it a lot better, or at least a lot of people like learning through games. And especially if you are wanting to train yourself or something, or you want to like keep yourself active, games are a very good way to like keep your mind active, always going, and stuff like that. So it's a really helpful tool to, you know, if you're elderly, to like keep yourself thinking and always doing something, right? And so there's also other applications, non-gaming wise. Unity is just a 3D engine. People call it a game engine because that's mostly what it's used for, but you can also use it for things like simulations. So if you want to simulate surgery so people can learn how to do surgery, it's better to do that on a fake 3D person than screw up in real life. So, stuff like that. And so today we are going to be covering Unity, but just keep in mind that there are lots and lots and lots of game engines out there, and even if Unity isn't your thing, the chance is that there's probably something else that is your thing, and I definitely recommend that you go online and just check things out, but we will be covering Unity today. So I'm going to be covering two things. So I'm not going to be writing too much code because me sitting here like, open curly brace, enter, semicolon. It's probably not the most interesting thing, and to be honest, I'd probably fall asleep if I watched myself code. I fall asleep coding myself, so I mean, whatever. So we're going to be covering mostly the editor, the basics of Unity, and how you can really navigate around and use this amazing tool to your advantage. I'll be covering some of the most basic foundational techniques when it comes to using the Unity editor, because one of the things that Unity is completely different than probably most of the things that you've done before is that you are really dependent on the editor to like get your game going. And most code is just like you do code. I mean, if you've done Android or something, maybe you've laid out your application or your web app or something, but it's really not on the level of Unity in terms of a collaboration between what you do in a UI and what you code in the backend. And so we're going to be using the editor, although if you really want to, you don't have to use the editor. It will make your life immensely hard, but you don't have to use it. So please use it for your own sanity. The language is C#. It's not C flat, not D#, no, it's C#. It's made by Microsoft. There's also other languages. There's the Unity language, which is essentially their own way of JavaScript. But me saying your own form of JavaScript already tells you we're not going to use that. We're going to be using C#, because C# is probably going to be most useful to you over other disciplines, because C# is used pretty much everywhere. So, hopefully your Unity editors have downloaded, or you downloaded the project or whatever and opened it up. Can I see a hand, like show of hands, like who has actually opened the project? Yeah, a few people? Cool. So I'm going to be switching over to the Unity. Okay, this is Unity. Oh my goodness, it is small. High DPI displays are problematic. So as you can see here, this is Unity and the text is really small, so I hope, can you guys sort of see, okay? Yeah? Okay. Unfortunately, I cannot make it bigger because they don't have scale, but that's the problem for another time. So this is the Unity editor. It looks very complex and formidable, and when you open it the first time, you're like, what the heck is going on? What's an untitled? I don't know what an untitled is, please tell me. So basically, chances are, at this point, you're asking yourself what's going on, and you would be very right to do so. So I'm going to cover a little bit of the panels. So if you have ever used a panel sort of software before, you know that you can drag these things around. So this might actually be looking a little bit different than what you see. So you can sort of like organize your space, you can move things around, you can shift these panels. You can make them look however you want. If you don't have, I would say the most important ones are the project panel, the game panel, the scene panel, the hierarchy panel, and the inspector. If you don't have those, you can go on window and they're somewhere in here. Or just say layouts and revert to factory settings or something like that. Oh, my bad. Okay, cool. So let's get into how to actually use the editor. So if you are in a blank scene like this, which actually shouldn't be the case, you should go into the scenes folder in the bottom, double click this scene, and you will be greeted with this wonderful thing. Also, please turn off your volume because I made my own sound effects, and you don't need to hear my wonderful voice twice. So let's just go through this and hopefully figure some stuff out. So it's obviously 3D. That's cool. And so if you right-click with your mouse and you move around, you can sort of look around, and you press the WASD keys like a shrewd gamer, and you can navigate around and see all the things and be like, whoa, clipping, where did the tree go? It's right there. Anyways, enough fun. So as you can see, we have a nice little scene here. You have your house, you have your tree, you have your grass. I made these models really quickly myself in Blender. Blender is an amazing tool to make 3D models, but I realized that 3D model making is hard. So I have 2 web pages at the very end that I'll be sharing with you guys where you can download 3D resources because they're incredibly useful to have. In fact, I would say that's kind of the point, so you might want some of those. Also, if you have noticed already, there's a very beautiful sort of sunset thing going on. This was created by someone on the asset store, and we have their permission to use it for this thing. Also, I can't show you the asset store because you're waiting. Oop-de-doo. Okay, well, let's continue on. So now that you have this scene, we want to shift our view over to the hierarchy panel. So there's a lot of stuff going on here. So you can like see these things and you have like this nested objects. It's basically like a file structure, except instead of a file structure, you essentially have all these game objects. And so these game objects are essentially just like things that you can nest in one another, and they have certain properties to them. And those properties are called components. So if we click on this rigid body FPS controller, you will see that there's a bunch of stuff on the right-hand side, and there's so many values, and oh no, math. So essentially, we're going to be wanting to figure out what these things do, and that's what I'm going to be covering today, a little bit. So without further ado, let's talk a little bit about this rigid body FPS controller. So this is something that I did not make myself. This is from the Unity standard assets. And so basically, it does this. You press the play button, that plays, by the way. You can look around and you can move and you can do things. Whoa, jump, yeah. So that's what that does. And so basically, Unity has some standard assets like that. So basically, things that you would expect to have in a game engine, like you want to be moving around, you don't want to be standing still, maybe you need some 3D models, they come in that, and you would basically go on this asset store tab and you'd look for Unity standard assets and you would find it. And so essentially, what this is doing is there's a bunch of these components, and this is where the inspector comes in. So you have these components on the right-hand side, and they define essentially what this object is, what it does, how it works. And so really what you're doing is you're taking essentially this empty sort of document, this empty game object, and you're attaching things to it, and by attaching things to it, you're giving it functionality, you're making it work the way that it does. And so you can think of these components sort of like a class is in an object-oriented programming language, because that's essentially what they are. They are classes. And we'll get a little bit more into how you can make custom components later in the workshop. And so some of the standard ones you'll see are transform. So essentially that just tells you where it is. You also have rigid body, capsule collider, and this script, this rigid first-person body controller script. You have this audio source, which at some point in time output footsteps, but I thought they were too annoying, so I sort of took them out. You can put them back in if you want. They're probably somewhere in here. But the idea is that this is where the editor part of Unity comes in. And so a lot of the interesting things about Unity with the editor is even though you can't do everything in code, this sort of really helps you organize everything and sort of put it together. And yeah, so the rigid body, I'll go over, I guess, rigid body and collider, and then I'll move a little bit more into scripts, and we can actually start doing some hooray. Okay, so a rigid body is essentially something that makes something solid. So if you look at this wonderful, okay, I'm sort of restricted on movement with the mic, but you see this, I touch the thing, and my hand does not go through, because it is physical, it is an object, and my hand should not go through this thing. But we have to tell a game engine that. Because it does not know that it is a object, and it also doesn't know where exactly the bounds of its existence are. And so a rigid body essentially gives it this sort of, I can't go through it. But then there's also these things called, when you put the model in, right? It's sort of like saying, oh look, here's a hologram. And then when you put your hand through, it goes through and you're like, oh, that's not supposed to happen. And so that's how you fix it. You have a rigid body and you have this thing called a collider. Now, a collider is related to a rigid body in the way that it tells you where you interact with it. So if I look at this thing, right, it's very simple that when you touch the surface, your hand doesn't go through the surface. But with certain things, or at least in the game engine world, it's a little bit harder because there's a bunch of complex calculations going in the background that define sort of the bounds of existence of this thing. And so, like, even though I can move this around a little bit, though, I hope that's not doing anything wrong. But you can move this thing around, you can touch it. But in Unity or pretty much any game, if you move out your hand and you move things around, it's probably not going to do anything. Which is also why we get this clipping effect, because you're partially in the model, but you're also partially not. And so that sort of explains some things. But the whole point is these sort of calculations to figure out where the bounds of an object are incredibly expensive to do for the processor and stuff, because there's all that math involved. And so typically what we want to do is we want to make things as simple as possible. And so in this case, we have a capsule collider instead of a, oh wow, the whole like human body collider, because I am touching things with my hands and stuff. Because typically speaking, when you're moving around as a character, you don't need all of this extra sort of collision space. It's just way too much math and way too intensive to actually like be useful. So for this thing, for example, for the stand, it's very squarish. So you might, for example, want to just give it a box collider, because it's just, it is like a box, right? It's kind of squarish, and it does the job just fine. Just, there's certain things that won't look quite right. Like, if I sort of like, I make it a little bit too tall, I sort of like tap here, and like, I can't go further than this because I sort of made the collider too tall, and I can't go into this space because there's something there. Anyways, enough about actually all these collider things and rigid bodies and stuff. So let's actually get into some of the stuff that you're probably more interested in, which is how to actually use the editor. And so if you're following along, you can essentially modify this level a bit. And so I have these things in here in this, I have this small island and this large island. And so the large island is obviously the large island, the small one's the one down there that no one's looking at yet. And so the large island, you see all these things in here called prefabs. And so prefabs are something that in your typical coding experience you won't really see. It's kind of like a pre-configured class. It's like a default of several classes put together. It's sort of like a group. And so, for example, I prefabbed this tree so that when I copy and paste this tree, all the other things go with it. So you just copy and paste it, and you can use these arrows to sort of move it around. You'll see I have a second tree, but when I'm on this tree, it still keeps its rigid body and collider, and that is because I essentially said this prefab has this sort of mesh to it, so it looks like a tree, and it also has all these other components that make it real and make it so that you don't walk through trees, which would be bad. And so you can essentially use the editor to your convenience to shift stuff around. And so this is called level design. You can make your level as nice as you want. You can move all these like grasses around. You can add extra stuff to it. And so typically, that's how you would do it. If you have 3D assets that you import, they appear in this panel, and you can drag and drop them into your editor, and you can use them. And so if you have some 3D models on your computer, you can go ahead and click them in, move them around. Also, all of these 3D models, if you want to use them in your own project, you can, because I made them, and if you want to use them, go ahead. All right, cool. Code, custom components. Yes, give me the code. This is a hackathon, not a lecture. All right, cool. So let's see. If you go in your scripts, you'll see I have these lovely C# scripts for you. Depending on the version you downloaded, some of them might have stuff in it, some of them might not. In this case, most of them already have some stuff in it. and we'll be hopefully adding some of our own sort of touch to it. I'm going to sort of go through some of the things that are going on here. Oops, this is not the script I want to see. All right. Let's actually, before we start, let's play the game. So the point of the game is you want to get into your house. You will notice that you don't have a key, so you can't get in the house. So you go over here. There it is. There's a key. You jump down. You get the key. You bounce on the trampoline way too high because that's how physics work. And now you go to the door. You unlock the door. You're like, yes, my house, because you want to get into your house because it's cold outside. Like, Davis is so cold all of a sudden. I don't know why. Anyways, so essentially what's going on here is a bunch of progression. So you get from one, yes?
Where's the cool voice?
The cool voice?
Yeah.
Oh, it's right here. Oh, do you want me to narrate? Okay, I'll narrate. I'll just do this real quick to satisfy all of you guys. Okay, here we go. Whee! Dun-dun! Boing! There's a door. Wow, a house. I can finally do my CS homework until 5 a.m. Okay, alright, cool. There we go. Okay. All of you have a chance to make all of your own cool sound effects and put this into this game later because we will do that. Okay, so, cool, trampoline. So there's several things that happened here. First of all, if you would have had the sound and I just didn't, I added my own sound effects, so you would have seen like I can't open the door because I don't have a key. And so we have this progression script here, which essentially keeps track of where you are in the level and what you have done. We also have this trampoline script, which essentially says you go up if you bounce on the trampoline. And you also have the key script, which allows you to pick up the key, and you have this door script, which says you shall not pass if you do not have the key. And so let's start off with the trampoline script. So how many of you guys have worked in C# before? A few of you, yes. I'm not too experienced in C#. I've only used it with Unity so far. So forgive me if I'm not the most knowledgeable about, I guess, making the C# script look really nice and coding styles and stuff. But I will do my best to sort of not make it look really bad. So we're going to start off a little bit with these public sort of entities. So usually when you make something public, it does what it means. You make it so that everyone can see what it is. And so in this case, this public game object player, this public enforce, I declared them because I want to be able to alter them when I'm in Unity. So in this case, you will see that I have a public game object player and a public enforce. If I go into my Unity and I go on the trampoline, I will see that I have these objects appear on the right-hand side. So it's this player and this force. And so essentially, this is where sort of the connection in Unity comes in. So you want to access stuff in your scripts because you want to be interacting with the rest of the game. And so this is what allows you to do that. It allows you to sort of do stuff from the editor and also do stuff from your script at the same time. And certain things are going to change. Like, that trampoline was way too bouncy, am I right? Like, no one wants to jump that high. You'll die if you fall on the floor because you were bounced into the atmosphere. So you can like play around with the force. I set it to 600, maybe 500 is a better number, 450 is a better number. And you don't always want to change that. And if you have more than one trampoline, maybe they should work differently. If you have a trampoline where you actually need to jump higher, you can put 700 or stuff like that. And it's essentially just, you have your default values and you have them where you can use them and so on and so forth. Specifically for this player model, I don't want trees to bounce. If I put a tree on a trampoline, it should not jump. Trees do not jump. Why is it jumping? So we make sure that we reference the player, and we make sure that when the player collides with the trampoline, the player jumps, because trees do not jump. So in this case, we have this thing on the right-hand side. You'll see this teensy little circle here, which is probably bigger on your screen. Unfortunately, it's tiny on here. It's just over here in the corner. And so you can press on that, and then it'll come up with this section on the left-hand side where you can select the game object. And so in this case, we selected the rigid body FPS controller because we want the player to interact with the trampoline. Now, usually when you make a new script, certain things will come up. You'll have usually a start function, which is void. because it's not supposed to return anything, and also an update function, which is also void because it's not supposed to return anything. The start function occurs when the script is first attached to the object and when the game essentially starts. Or not when the game starts, when the object appears in this universe that you have created. And so what ends up happening is this update function runs essentially every frame or every tick in the game. And so if there are certain things you want to update over time, the update function is the place to do that. In this case, they aren't in here because we aren't using them, but there are plenty of cases in which you would, and so I just wanted to sort of clarify what they do when you come across them. In this case, we have a void on trigger enter, and so what this does is, if we go back into our trampoline, you will notice something. We have this mesh collider. We don't have a rigid body because we really don't care if we flip through the trampoline, but it does have a trigger, and so what the trigger does is, it essentially says, this object now has a listener. If something interacts with this object, I'm going to execute this function, and this collider gives me information about the collision that just occurred. And so, obviously, there's many points in games where you would want to have something like this. So, for example, if you are just navigating around, if you interact with the door or you get close to a door, you want to be able to press a hotkey, see, oh, I'm connected to the door, and then you can open the door, and stuff like that. And so there's loads and loads of sort of ways in which you would want to use these colliders. In this case, I use it to bounce. So, in this case, what I do is I check first if the collision, and if I collided with the player. And so I use this collision.gameObject.name, which essentially gives me what I collided with, and then the name of that. And then I cross-check with the player.name. If that all adds up, I essentially execute this thing. And so this function, or this sort of way of using things in Unity, is probably the most important thing. So you are going to want to interact with components. Components are the bread and butter of your game objects. Without components, nothing happens. It just exists. It doesn't do anything. And so components are what allows you to do something. And so in this case, we go on our player, because we collide with our player, we get the component, rigid body. And so this is a templating thing. I'm assuming, are any of you guys, raise your hand if you're a first year. Raise your hand if you're in object-oriented programming. 36B. Have you come across templating yet? Yes? No? Okay, cool. A little bit of sneak peek preview if you haven't gone to templating yet. Templating essentially fine-tunes something to work with a specific type of object. So in this case, when I say get component, rigid body, I say I want to get the rigid body component, specifically that. So this is a sort of templating thing. I'm not going to go into the specifics because otherwise I'd be sitting here for 2 hours instead of just one. But yeah, it's a function, it gets the rigid body. You can replace this with whatever component you need. If you need to interact with your collider, capsule collider, or whatever else you have on there, you can. And it will also allow you to do some really cool things like generate your own meshes. So if you want to have some infinitely generating world, you can access the mesh and you can generate your own thing. It's really cool. Anyways, so we get the rigid body because it is our physics for this object. And in this case, I add a force, which is the transform.forward force. Don't ask me why it's .forward, because it should be .up, but for whatever reason, my game is really weird and it does weird things, and so it's transform.forward. Usually it's going to be transform.up. It's basically the direction in which you're pointing. Anyways, I multiply it to this force factor, which is what I defined up here, and this is one of the reasons you want to have that as a public thing, because depending on what your names. And there's this force mode.impulse, meaning essentially that one split second you apply the force. You don't apply it over time. It's just this one split second. And so once that happens, you jump. And that's what the trampoline script does. And so you can do all sorts of interesting things. And so right now, you get to open up your voice recorder. I'm just going to sort of show how this works and go a little bit about how you import your files and stuff. So I want you to record your voice, and I want you to do the most convincing trampoline sound you can do. Okay, so let's start. 4 There we go. All right, cool. I embarrassed myself for no reason. Let's go into assets. Let's go into our audio clips. There we go. We have these 3 wonderful audio clips. We're going to do the following. We're going to go into the documents. Where's the thing? Boys. Recording. And, oh, it came up for a second. There we go. Is that the right one? I do not know. I think this is the right one. So in this case, if you go in your files, you just drag and drop this into your audio clips. Cool. Now you have it there. And that should, in theory, work. Oh, shoot. Yeah. Okay. Let's hope that you can convert or have something that records to like MP3 or WAV, because apparently they don't support M4A. So if you're using your voice recorder, your standard one on Windows, it probably won't work. But how do you guys think one would go about this? Any volunteers? Yes? No? Okay. About how you would add a sound to your game.
We try to like click on the trampoline and then kind of add a
Yep.
sound there.
Oh, add sound, alright. Let's see. Also,
Or like
audio source, something like that, right? Okay, cool. We also want to be able to control when it plays and stuff like that. I'm actually going to open up another script. I'm going to open up my progression so that I can copy and paste code like a true programmer. Alright, cool. So I'm going to copy and paste this thing. Wonderful. Yay. Copy and pasting. Stack Overflow. Okay, there we go. So in this case, this is what the command is. Also, I'm copying and pasting because I want to make sure that I get it right and I don't say the wrong thing. And also, my internet doesn't work, so I can't check any documentation to make sure that I'm not going insane. All right, cool. So in this case, we play one audio file. And so in this case, an audio file, we want to sort of, I guess, import it like these other things. So we have this game object and this enforce, and we're gonna like use our audio file just like that. We want to be able to define it. So let's call it boing or whatever, right? So you would do public, whatever the sort of object for audio is. In this case, it's audio clip. You do audio clip. And so in this case, if you go back in here and we're on the trampoline, this thing should update. There you go. Wow, new field. And so in this case, we have the boing field. And if you go in here, you will see all of the audio stuff. And so in this case, you could set it to wherever your audio file is. So this. It's not the right one, but you sort of get the point, right? And so that's how you would go about essentially importing your assets, using them in your game, and using them efficiently in scripts. If you really want to do it not the easy way, there's probably other ways of being able to import directly from your assets, but doing it through the editor is the easiest way, and you should not do it any other way unless you really, really, really want to, or if there's a situation that requires it. All right, cool. Let's talk a little bit about the other stuff that happens. Specifically with instances and how you can instantiate them, how you can delete them and stuff like that. Because for the key, it's very obvious that once you have one key, you do not want more keys. You do not want infinite keys. You don't want it to stay there, because otherwise you've got this problem that, oh wow, I have like 10 million keys, and this audio clip is like, because you're playing the same audio clip over and over and over and over and over again, and it's just really annoying, and you don't want it. Trust me, okay? And so essentially what we want to do is once we get the key, we delete the key, because one key. Okay, cool. So essentially there's a bunch of commands, and I will refer you guys back to the Unity documentation. I'm not here to code, because that's your job, since most of you guys are sort of like, okay, which of you guys are in CS? Are there any artists in the room that would like to raise their hands? Artists. Wow. Okay, 0 artists, cool. This is the complete opposite of Game Dev Club usually, by the way. So usually when I first did this workshop in Game Dev Club, it was mostly just towards artists. So I'm sort of struggling on getting the code parts in that you guys are probably very interested about. So I'm just I'm basically trying to get you guys used to Unity as a game engine, and assuming that you guys know how to read documentation. So in this case, once we get this, right, we want to destroy this .game object. We can also instantiate new ones. So if, for example, you have a ninja that spawns infinite katanas and just keeps on throwing them, like this, or ninja stars or whatever, right? You want to be able to spawn new ones, and so essentially you can instantiate new game objects, and then once they hit something, you want to destroy them, because otherwise you get one of those weird things where it's like, oh wow, Skyrim, but I spawned 2,000 pumpkins and my game crashed. Stuff like that. And so you don't really want that, so you want to destroy things once you're done with them. And that's what this does. Also, neat little introduction to, so far with components, we've mostly covered the ones that are standard in Unity, like rigid bodies and colliders and stuff like that. But your scripts are also components. They're just as much components as everything else is. Except Unity provides these standard components that are rigid body and collider. But if you want to access your scripts as components, you do it the same way. And so as you can see up here, we have a public class key. And so if you ever want to access this class, right, you would get the component that is key. And any public functions that you have in there, you will be able to execute. So in this case, I get the player, I get the component progression, and I say that he has found the key. And this is so that I essentially communicate with the player and I say, you have now reached the next step in your journey. You have found the key, you can now enter your house, and you can code away for the next 24 hours. So, in this case, when we go into our progression script, you will see I actually have this public void found key. I say that the key is now true. And I also say that the audio source is like that. I basically play this thing that says, wow, I got a key, woo. Okay, cool. Also, I have this private bool key equals false. I only really want to be able to change if I have the key or not. If I play this thing, I don't want to accidentally say, I found the key and not play the audio clip associated with it. And so you might want to do stuff like this to essentially make sure that your game is working as intended. And so using these sort of functions and not modifying the values directly is in your best interest, as is usually the case with object-oriented languages. Usually you want to keep things private and use things like getters and setters to actually modify it. And so that's what I do in this case. So, next, and interesting. Also, oh yeah, look, I do have an update function. And I'll tell you what this one does. Because sometimes interesting things happen. Like, the player's like, oh no, oh, cool, I respawn, yay, okay, cool. And so essentially what this does, in this case, is that the update function essentially looks, where am I located at? And so this .transform is actually one of the things that you're probably going to be using the most. It keeps track of where you are. And so where you are is usually very important in a game. And so even though you don't have to do things like your own physics engine or like your own render and stuff like that, because Unity handles the complicated stuff for you, you will want to check certain things like where you are. And so in this case, I constantly check every frame if my position has fallen under this sort of limit. And that limit is the bottom of the world. And so if you fall into the void, you do not want to be constantly falling into the void, because the game isn't fun if when you die, that's just it. And you need to like restart your game or something. Or some games are so crazy they delete your save files and stuff like that. So you don't want stuff like that. We want our games to be fun and entertaining and stuff like that. And so we essentially use this command, which is, instead of putting our player back where it is, I mean, basically, usually you will want to do something like that. You want to put your player back where they are, but I wanted to introduce this sort of mechanic, the scene manager. And so, really, a game isn't usually just one scene. I mean, there are games like that, but usually you will have like multiple things. Like if you go into a house or something, it loads a new scene, or there's a bunch of different worlds that you can explore and stuff like that. And so the scene manager is your friend. You will notice that at the beginning of the workshop, we went in here. Oh, yeah, I'm going to stop this game. There we go. We went into our scenes, and I double-clicked on this thing. And so our scenes allow us to essentially manage things and set them apart. This is also very important because imagine this, you have this sort of infinite world, right? Or like a really big world, and you're essentially loading all of it at once. That is a terrible idea because that exerts so much pressure on your system to like just load everything. And so usually having these sort of scenes is sort of, I mean, your game might still be like a very big file or whatnot, but it will definitely like help you load things because you don't have to load all these meshes at the same time. And so it really helps with essentially loading things, also making sure that the player progresses as intended and stuff like that. And so you will want to use these multiple scenes in all these sort of occasions. And so this allows you to do that. If you want to make a new scene with a new set of islands, a new level or something like that, feel free to. So you can just go in here, you can duplicate this scene. You can do like Control D, yeah, Control D. You can open this one up. Let's just save our current scene. As you can see, duplicated. You can now move stuff around. Also, it didn't duplicate with a new tree because I didn't save it before I duplicated. I saved it after I duplicated. So now you can like move stuff around. You can have a different level, and you can, in your scene manager, go in and you can choose the level that you want to load. In this case, I chose application uploaded level because I wanted to reset the level that I was currently in. Also, another reason why if you like fall below, if you want to like reset progression and stuff like that, you might want to load scene again because it essentially brings the key back to where it was, and it also undoes the fact that I found the key in the first place. So it essentially just is like you started this scene again, like it's new, brand new. And so in this case, we have one last function, which is check door, which essentially is when I go to door.cs, I say if I collided with the player, I once again want to call a function, the progression, which is checking the door. And so in this case, I call this function, and I essentially check, did I get the key or not? And depending on if I got the key or not, I will play a different audio source file. Cool. That's sort of the basics of scripting in Unity. There's far more stuff to discover, and there's loads of things that you can do. To give you an example, yes, you can randomly generate a world. You can use these, there's a bunch of different components too that I didn't cover, like the animation component and stuff like that, so you can like increase or like include animations. You'll see all of this different stuff. There's also incredibly interesting things like you can train an artificial intelligence to find a certain path through a maze, and there's been like interesting studies where, for example, they took like this room, there's two rooms, right? And there's this like hide and seek situation. There's two seekers and there's two hiders. You have the room and you have two blocks that the hiders can use to block the doors so the seekers can never find them. And so essentially it starts off with them not knowing what to do except that they can move around. They don't even know that they're looking for one another. They just know if I win, that's good. And so you have them sort of aimlessly wandering about until one party wins. And they remember that, and then the next time, you know, the seeker is like, let's see, where are the hiders? And they go for the hiders, and then they try to get them and stuff like that. And it also like exposes some interesting sort of glitches. So for example, in one case, the seeker sort of walks into a wall, glitches, jumps out of the level into nowhere, and then suddenly ends up in the room. And so they'll find stuff like that too. And so there's really cool stuff in terms of simulations and stuff that you can do in Unity. And so really, I just sort of scratched the surface today, as is sort of the intention of a workshop. But with sort of the knowledge that you've gotten out of this, you should be able to make your own game sort of from scratch. That was the goal. And so, like I said, there's lots of things that you can do. I forgot, I think the company was called Aging 2 or whatnot. For example, making a game or something to help seniors, because a lot of games are really like fast-paced and stuff like that. If you make sort of a slower, more like logical game, or like where it involves a lot of thinking, that might be great to like help people out and stuff like that. Or if you want to do a learning game for academics, so you want to teach someone physics, for example, you could easily do something like that in Unity, and it's really something you might want to look into. Although I assume at this point, probably most of you have already started, I hope, right? But, you know, if you want to include it. So I'm going to go over one last thing before I go over some of the resources and stuff. you will probably want to export your application at some point in time because you don't want to share your project with someone and be like, okay, so first you download Unity and then you open the project and then you press this big play button and then, whoa, 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 I just want to run an executable file. They have a good point. So I'm going to show you not how to make an executable file, but probably something that's way better. So when I first started game development, back in my day, I had no thing called WebGL. Now there's this beautiful thing called WebGL, which allows you to run a game in the browser. And so when you go into your build settings, you'll see this thing called WebGL. It essentially uses this thing called HTML5 canvas to generate your 3D graphics. And this runs in the browser. So that means, for example, this is incredibly useful because I don't know if you guys know, but probably some of you at some point have probably used like a Chromebook or something, right? Chromebooks usually don't run too much stuff. I mean, they can even run like Linux nowadays, but this will run regardless of the device. This will run on your mobile phone because you can run it in essentially every single browser, and it makes your games really, really accessible, and I recommend using it. Of course, you can also do it for PC, Mac, and Linux, but and those will essentially help you boost performance. They will run a lot faster than WebGL does, but if it's something simple like this, WebGL is a really good platform to use, and you have also all of this other stuff. So you would essentially choose which scenes you want, and then you would click on Build and Run. I can't click on Build and Run in this case because I didn't download the SDK for it. If I go on PC and Mac, I can press Build and Run, and it essentially makes this executable for you that you can double click and it runs. It's pretty cool stuff. So you can boast to your friends how cool your voice sounds when you say boing. Also, I guess a few final things that are important, and then I'll get to questions and stuff because I know I've been rambling on, and I usually tend to do that, so I'm sorry if I rambled on and some of you guys were raising your hands I didn't see. Hopefully that wasn't the case. Lights and cameras. So essentially when you set up your scene, you will want to be able to sort of control what you see, how you see it, and stuff like that. So these sort of directional lights, if you right click, or actually let's say it this way, if you do, game object, 3D object, there's a whole bunch of different stuff that you can choose. Also effects like particle systems and stuff. Particle systems are really cool, by the way, but unfortunately they're not like easy to understand or learn really quickly. But lights, directional lights, point lights, spotlights really help make your scene what it is. And so I highly recommend like playing around with them, placing them in different parts of your level, sort of understanding how that works. Also, you can make cameras. There's just one camera, but essentially, my bad. In this case, you have your character, and when you walk around, you want the camera to follow the player. So in this case, we like nested the camera under the player. And so you can put your cameras in a bunch of different places. So for example, if you want to make like a third-person top-down thing, you can sort of have the camera looking down and follow it. And that's where you use that transformed position. You would essentially like look at where the character currently is and then offset the camera based on that. And stuff like that. And so you can essentially use all of this stuff to your advantage in different ways. All right. So I'm going to end off with any questions and stuff. Anything you want to see that I could possibly do quickly? Questions? Hands? Okay. So in that case, I'll go into some of the resources that you guys can check out. So I don't know about you, but I read documentation on the weekends. It's lovely. I like print them out. I like read. No, I don't really. But documentation is incredibly useful, especially in Unity. There's so much different stuff. Like, I can't explain all the stuff that's in Unity. There's just way too much. It's impossible. And so if you ever have something specific, chances are Unity forums or Unity documentation has got your back, and you can find stuff in there. So highly recommend looking at that. There's also an incredibly helpful YouTube channel. He's an amazing guy. His name is, well, I don't know what his name is, but on YouTube he's called Brackies. And so essentially, he does a bunch of cool stuff in Unity. Some of the stuff that you'll see on his channel, like, it's really interesting. That's all I say. Like, you will look at it and you'll be like, oh wow, I did not know I could do something like that in Unity. And so, really recommend his channel. It's very fun to watch. And he somehow makes looking at code interesting. All right. And also use last two resources for downloading 3D models because let's face it, if you were to make your own 3D models, or if I make my own 3D models, they probably don't look too good, especially like if you want to make like player models and stuff. So I highly recommend downloading them from there. And the Unity Asset Store also has some amazing stuff in there, like this rigid body FPS controller that you can install at the start. All right. Any questions at the end? No? Yes?
I'm just curious about that hierarchy of the objects online.
Yes.
I just think why is it organized in that way?
Okay, cool. Everything is a game object. Have you worked with HTML before? So essentially, think of everything as a container. So you know how you have like those little Tupperware containers, right? And you can put like smaller Tupperware containers and the bigger Tupperware containers. So think about each one of these sort of things like a little Tupperware container that you can put various stuff in. And so essentially, what this hierarchy is it's a bunch of Tupperware containers with other Tupperware containers inside of them. And so I know that's not probably not the best analogy, but it allows you to sort of move things around. But thank you for asking that question, because there's something else that you might want to know. So position, right? In this case, you see that I have this sort of grid here, and everything is based off of this grid. At least that's global position. There's also local position. And so where local position comes in is certain things are placed relative to other things. So for example, this large island, right? I can sort of take this large island and let's say I want to move it around a little bit. I change this, right? It moves it up, right? But it moves the whole thing up. It moves everything up, including the contents. And that is because, not because when I go on the rock, this position or this rotation or this scale changes, because that stays exactly the same. And I'll prove it to you. I'll go in here, right? Okay, look at the rock. It has this position, 6.2546 or whatnot, right? Let's change this to 12. And if I go on this rock, it still has the same position, exactly the same. And that is because this rock is placed relative to the parent object. So this is the large island would be the parent object versus these rocks, trees, houses. They're the children of that parent object. And so this relative positioning allows you to do a bunch of interesting things and allows you to sort of group stuff together. And so that's part of actually what makes what's a little bit tricky to understand about a game engine. So sometimes when you're playing around with position, you will have to differentiate between position and local position, because depending on what you choose, things might screw up a bit. Good question. Any more questions? No. Okay, cool. I guess I'll hand it over to Zuli for final sort of outro.